Right, in this video, we're going to talk about suggested homework problems for section 1.3. And we'll be using some more analytic methods. Last time we used the tabular method to kind of approximate the limit. Here we're going to find the limit exactly. So first we start off with a polynomial function that's we're going to be able to use direct substitution for. So as x approaches -3, x squared plus 3x, we'll stick in -3 for our x. And we'll learn more when we talk about continuity, why we're allowed to do this. Our answer is going to be 0. And just check that there, that x squared plus 3x, when I evaluate it at -3, 0. Okay, so clear. Let's move on to number 19 here. Limit as x goes to 1, x over x squared plus 4. It's okay to just direct substitution here as long as the denominator is not going to be 0. So this is 1 over 1 squared plus 4. So 1 over 1 plus 4 is 1/5. So now at 21. Limit as x goes to 7 of 3x over root x plus 2. My domain here is -2 to infinity. So 7 is in my domain. I'm allowed to use direct substitution for all these elementary functions as long as the c value is within the domain. So 3 times 7 over root 7 plus 2 is 21 over root 9 is 21 over 3 is 7. All right. Next question is 25. And we're told f of x is equal to 4 minus x squared, and g of x is equal to root x plus 1. And we're asked to find the given limits. So A says limit as x approaches 1 of f of x. So that's a polynomial function. I can use direct substitution for it. B says limit as x approaches 3 of g of x. That's within the domain of g, so I can use direct substitution. And C, limit as x approaches 1 of g of f of x. I already found limit as x approaches 1 of f. So this is going to be g of 3, which I just found here was 2. So using the previous answers, I can evaluate there. Let's go ahead and look now at number 27. Limit as x approaches pi over 2 of sine x. So we're on the unit circle, approaching pi over 2 from below and above the sine value. Cosine sine is getting close to 1. Limit as x approaches 1 of cosine pi x over 3. So that's the same thing to me as saying limit as x is approaching pi over 3 of cosine of x, getting close to pi over 3 here. And then this is cosine sine, so that's root 3 over 2 for sine, and that's 1/2 for cosine. So this is getting close to 1/2. And then 31 is limit as x approaches 0 of secant 2x. That's getting close to secant of 0, which is 1. And let's see now, what's the next problem here? 35. No, 37. There it is. And given that limit as x approaches c of f of x is equal to 2/5, and given that limit as x approaches c of g of x is equal to 2, let's find limit as x approaches c of 5g of x. So the 5 can come across, and that'll be 5 times the limit as x approaches c of g of x is 5 times 2 is 10. For part B, limit as x approaches c of f of x plus g of x is limit as x approaches c of f of x plus limit as x approaches c of g of x is going to be 2/5 plus 2 is 12/5. And C, limit as x approaches c of f of x times g of x is limit as x approaches c of f of x times limit as x approaches c of g of x is 2/5 times 2 is 4/5. And D, limit as x approaches c of f of x divided by g of x is limit as x approaches c of f of x divided by limit as x approaches c of g of x, and so limit as x approaches c of g of x is not 0. So that's 2/5 divided by 2 is 2/5 times 1/2. 2's will cancel and give me 1/5. All right, that was 37. Let's look now at 43. So now we want to use algebra to simplify, to remove the point of discontinuity and evaluate a simpler function where that has the same limit. So if I would try direct substitution, I would get 0/0, and that would tell me to try this process here. So limit as x goes to -1, we're going to factor the numerator x plus 1, x minus 1 over x plus 1. This is the factor that was giving me 0/0. It will agree with the limit as x approaches -1 of the remaining part x minus 1. So that will be -1 minus 1 will be -2. Let's look now at number 51. limit as x goes to -3, x squared plus x minus 6 over x squared minus 9. Let's limit as x goes to -3. This is x plus 3, x minus 3 in the denominator. And this factors into x and x, plus and minus. This is plus 3 and minus 2. 3 minus 2 is 1. 3 times -2 is -6. X plus 3's will cancel, leaving me with limit as x approaches -3 of x minus 2 over x minus 3. So that's -3 minus 2 over -3 minus 3 is -5 over -6. And divide out that -1 to give us 5 over 6. Exactly. Now let's look at number 55. We're going to have to rationalize the numerator for this one. Limit as x goes to 0, root x plus 5 minus root 5 over x. So we're going to multiply by root x plus 5 plus root 5 over root x plus 5 plus root 5. So limit as x goes to 0. Use that difference of two squares property, that a minus b times a plus b is a squared minus b squared, to help you square these square roots to get rid of them. So that square root squared is x plus 5 minus that square root squared will be 5. Leave that denominator factored. Don't try and put it together. It won't be super helpful for you to do that. This is going to be limit as x approaches 0 of x over x times root x plus 5 plus root 5. And the x's will cancel each other out, leaving you with a 1 in the numerator. Limit as x goes to 0 of 1 over root x plus 5 plus root 5. When we evaluate, will be 1 over root 5 plus root 5, or 1 over 2 root 5. Rationalize that if your teacher tells you to by multiplying by root 5 over root 5 to get root 5 over 10. (57) Limit as x goes to 0 of 1 over 3 plus x minus 1 over 3 divided by x. And so we're going to need to make a common denominator in the numerator. So this is going to be limit as x approaches 0 of 3 times 3 plus x minus 3 plus x over 3 times 3 plus x. And this is going to be divided by x. So this is going to be limit as x goes to 0 of 3 minus 3 is 0. That's a negative x over 3 times 3 plus x times 1 over x. Cancel that multiplies to give me limit as x goes to 0 of a negative 1 over 3 times 3 plus x will be equal to a negative 1 over 3 times 3 plus 0, or negative 1 over 3 times 3, which is a negative 1/9 for my limit. Let's look now at number 59. Limit as delta x goes to 0, 2 times x plus delta x minus 2x over delta x. So we have 2x plus 2 delta x minus 2x over delta x. Limit as delta x goes to 0 is limit as delta x goes to 0 of 2 delta x over delta x is limit as delta x goes to 0 of 2 is 2. look now at number 63. And we're going to start using our special trig limits here. So remember that the limit as x goes to 0 of sine x over x is equal to 1. Likewise, the limit as x goes to 0 of x over sine x will also be 1. The limit as x goes to 0 of 1 minus cosine of x over x is 0. And the limit as x goes to 0 of cosine of x minus 1 over x is also 0. Write all those down. Your book may only give you one of each of these forms. I think it gives you this one and not the other two. The reciprocal of 1 is 1. The opposite of 0 is 0. So you will need to know that you can reciprocate this first one, and you need to know that you can multiply the second one by -1 and that they won't change. All right, we must make these show up. We'll do something called U substitution here if we need to. Let me show you what I mean by that so that we're not kind of lazy with our rules. But let's pull the 1/5 out here. This is 1/5 limit as x goes to 0 of sine x over x. We have that identity, that theorem right there, that equals 1. So my limit is 1/5. Now we have limit as x goes to 0 of sine x times 1 minus cosine of x over x squared. So I'm going to split the limits. Limit as x goes to 0 of sine x over x times limit as x goes to 0 of 1 minus cosine of x over x. That's 1 times 0 is 0. For 67, limit as x goes to 0 of sine squared x over just 1x is limit as x goes to 0 of sine x over x times limit as x goes to 0 of the extra sine x that's left over. This is 1 times, and that limit is 0, so that's 0. Let's look at 71 next. Limit as x goes to 0, 6 minus 6 cosine of x over 3. So I'm going to pull the 6 out from the numerator and the 3 from the denominator, leaving me with 1 minus cosine x here. Actually, I don't even need to do that. Limit, because there's no x at the bottom. 2 minus 2 cosine of x. There we go, like that. And this is limit as x goes to 0 of 2 minus 2 limit as x goes to 0 of cosine of x. So this doesn't change. That's a 2. 2 times, and then that's 1. So that's 2 minus 2. That will be 0. That problem would have been a little harder if it would have had an x in the denominator. 73, limit as t goes to 0 of sine of 3t over 2t. So I need to get rid of this 2. It's not helpful. I'm going to pull it out as a 1/2. And then I need the 3t inside of the sine to match with the denominator here. So I'm going to multiply by 3 over 3, like so. I'm going to get 3/2 limit as, and then I'm going to say if t is going to 0, let's multiply by 3 on both sides there. So 3t is going to 0. Sine of 3t over 3t, and this, and this all match, which is what I need for my identity. So that's going to be 3/2 times 1 is 3/2. I'm calling it an identity. Your teacher may just call it a special trig limit. So 85. Let's use the limit of the difference quotient here. We won't know exactly why we're doing that until the next chapter. This will be the definition of something important in calculus. F of x is equal to x squared minus 4x. Let's find the limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x will be limit as delta x goes to 0 of x plus delta x squared minus 4x plus delta x minus my original function x squared minus 4x over delta x. I don't really have anything of a higher degree here that really forces the need to talk about Pascal's triangle, but I would recommend that you look that up. For expanding these binomials if you get something of higher degree, and I might do a separate video on that at some point, or you can go back and look. I've talked about that in other places as well. So in my videos. So this is going to be x squared plus 2x delta x plus delta x squared by way of the binomial theorem, minus 4x minus 4 delta x minus x squared plus 4x over delta x. Anything without a delta x in it must zero out. All the things in the original f of x must zero out. So that leaves me with a common factor of delta x in the numerator. I'm going to factor that out and get 2x plus delta x minus 4 over delta x. Delta x's will cancel. This will give me the limit as delta x goes to 0 of 2x plus delta x minus 4. The delta x is going to 0, leaving me with 2x minus 4. Take a look at my original, and that is correct. So let's look now at number 89. If f of x is equal to 1 over x plus 3, I want limit as delta x approaches 0 of x plus delta x plus 3 minus 1 over x plus 3. All that is divided by delta x. Make a common denominator here, x plus 3, x plus delta x plus 3 over x plus 3 times x plus delta x plus 3 times 1 over delta x. Limit as delta x goes to 0. X minus x, 3 minus 3, so limit as delta x goes to 0 of, that's going to be a negative delta x, x plus 3, x plus delta x plus 3 times 1 over delta x. Delta x's will cancel, leaving me with a negative 1 in the numerator. Limit as delta x goes to 0 of negative 1 over x plus 3, x plus delta x plus 3. And the delta x is going to go to 0, leaving me a negative 1 over x plus 3 quantity squared. All right, a couple application problems to finish up here. 101 and 102. These are physics-based, so a construction worker drops a full paint can from a height of 500 feet, S of 0, is 500. How fast will the paint can be falling after 2 seconds? So we're going to use this S of A minus S of T. So S of T is equal to negative 16T squared plus 500. I'm going to need to find S of 2. It's negative 16 times 2 squared plus 500 is negative 16 times 4 plus 500. Let's just use my calculator for this. Negative 16 times 4 plus 500 is 436. And so the velocity after 2 seconds, so limit as t approaches 2 of 436 minus the function S of t, so that's minus a negative 16t squared minus 500 over 2 minus t. So that's going to be limit as t goes to 2 of 16t squared minus, let's see, so negative 500 plus 436, a negative 64. I'm going to call this a negative t minus 2 right here. That's going to be limit as t goes to 2 of 16 times t squared minus 4, negative t minus 2. So that's limit as t goes to 2, 16 times t plus 2 times t minus 2 over negative t minus 2. T minus 2's will cancel, and that gives me a limit as t goes to 2 of negative 16 times t plus 2 is a negative 16 times 2 plus 2, and negative 16 times 4 is a negative 64. And that's going to be in feet per second. So feet per second. 102 is going to be a little bit more complicated. A construction worker drops the can from a height of 500 feet. When will it hit the ground? So we want to find 0 equals negative 16t squared plus 500. And I'll just go ahead and call this TA because it's going to be the A that we're interested in our formula later. And so I want let's see, divided by 16 is math. Answer to fraction. So this is negative 16 a squared minus 125 over 4. So this is 16 times a plus 5 root 5 a minus 5 root 5 over 2. And then so a equals negative 5 root 5 over 2 doesn't make sense since it's the time. Or a equals 5 root 5 over 2. That makes sense for the time that it hits the ground, but that doesn't sound like something that I would tell somebody in real life, because they're not going to understand 5 root 5 over 2. So I'm going to need to tell them that's about 5.59 or 5.6 seconds. Approximately, it's exactly 5 root 5 over 2, but it's approximately 5 6/10 seconds. So let's go ahead and let's find the limit as t approaches 5 root 5 over 2 of 0 minus a negative 16t squared. That's going to be minus 500 over 5 root 5 over 2 minus t. It's going to be a little messy, like we said before, but the top is going to factor here 16 times t squared minus 125 over 4 over negative t minus 5 root 5 over 2. And this is limit as t approaches 5 root 5 over 2. So this is limit as t approaches 5 root 5 over 2, 16 times t plus 5 root 5 over 2 times t minus 5 root 5 over 2 over a negative t minus 5 root 5 over 2. These will cancel. That's limit as t approaches 5 root 5 over 2, negative 16 times t plus 5 root 5 over 2 will give me a negative 16 times 5 root 5 over 2 plus 5 root 5 over 2. It's negative 16 times 5 root 5 is negative 80. 5 times 16 is 80. Negative 80 root 5. Let's approximate that. So this is negative 80 root 5. And this is going to be about negative 178.89 feet per second when it hits the ground. All right, that's it for this video. And we will come back next time and talk about suggested problems from 1.4. See you for the next video.